Okay, so we just went forward about a minute. He explained his solution to his puzzle about those equations, and now he's on to something that says a prime in the form 4n plus 1 can be written as the sum of two squares. Okay, now I don't know if we're going to be able to figure this one out or not, but first I want to do a couple of examples. So why don't you find me some primes in the form 4n plus 1?
So 5.
Okay.
So
I'm gonna write 4n plus 1 up here just so we remember what we're looking for. So 5. Can 5 be written as the sum of two perfect squares?
So 4 squared plus 1 squared.
5 is 4 squared plus 1 squared?
2 squared. 2 squared plus 1 squared.
Ah, okay. What's 4 squared?
16.
Yeah.
But this goes to 17, which also works.
Oh, interesting. 17 is of the form 4n plus 1, and it is 4 squared plus 1 squared. Can we find one where we don't have a 1 squared?
Well,
So we need a prime that's one more than a multiple of 4.
Oh, 13.
13.
it's 3 squared plus 2 squared.
Interesting. Okay. It seems to work.
Yeah.
Well, at least for the first few examples. Let me pick a challenging one. 93. Oh, 93 is not prime.
Nope.
But 97 is prime.
97.
And 4, since 4 goes into 100, I know 4 goes into 96. So why don't you tell me about 97?
So, let's see. So how would we write that as the sum? So, what if we did 9 squared? That's 81. So that means we need
We would need a 16.
16, which
so
is 4 squared. So 9 squared is 4 squared.
Okay. So we're not going to explore why every prime of this form can be written as a sum of two squares.
Alright.
But I'm going to see if you guys can figure out what I hope is a slightly easier problem, although I'm not sure. But there are also primes of the form 4n plus 3. And let's see if we can figure out why these are not able to be written as the sum of two squares. So first of all, find a prime of this form 4n plus 3.
19.
19. Great. Is it a sum of two squares?
I'll already see why these can't be written as a sum of squares.
Oh, really?
Yeah.
Oh, wow.
I think it would have
awesome.
something to do with mods.
All right.
Because you could either have 0, 1, 2, or 3 mod 4.
Okay, so you're going to look at mod 4. And I can have 0, 1, 2, or 3. All right, so good.
So 2 doesn't matter for this, so all the primes are going to be odd.
Okay, good. So we're going to ignore 2 as a prime because
It's not relevant in this problem.
right, all the primes we're looking at in either 4n plus 1 or 4n plus 3 are odd. So 2 doesn't come into play.
So then we have to... So 4n plus 3, it has to be the sum of two squares, but... So an even number squared is always going to be a multiple of 4.
Okay, an even number squared, I'll write that as e squared, is always a multiple of 4. Why is that? Can you tell me?
Well, that means e has to be multiple of 2, so it has a 2 in it. So you have 2 squared in it.
Okay, great.
So that's 4. So,
All right.
Yeah.
And then odd numbers squared, there's two options. For if it's 1 mod 4, then the square is also going to be 1 mod 4.
All right.
And if it's 3 mod 4, it would be 9 mod 4 squared, which is just to 1 mod 4.
Oh, so interesting. So all even numbers,
Or odd numbers.
sorry, all odd numbers squared are 1 mod 4. What do you think about that?
Interesting.
So 3 squared is 9, which is 1 mod 4, 1 more than a multiple of 4. 5 squared is 25, which is
It's 1 more than 24.
7 squared is 49, which is 1 more than
48.
48. So look at that. So all odd numbers squared are 1 more than a multiple of 4.
So with 2 squares, you cannot get to 4n plus 3.
Yeah, so when I add 2 squares together, I can't get to 3 more than a multiple of 4. Pretty neat, huh?
Interesting.
So let's see what let's see what Jacob Lurie has to say about these primes and sums, and maybe he'll explain why 4n plus 3 can't be written as a sum. Or sorry, 4n plus 1 always can be written as a sum. And who knows, maybe he'll talk about 4n plus 3 as well. All right, let's see what he says.